right, let's talk about moment of inertia. And this is a property of a shape. So let's take a look at a couple of shapes here. We're going to be looking only at rectangular prisms. So there's two different ways to arrange this. You could have the same dimensions but organized a little bit differently. But if you look at the bottom here, we are going to call this the base, and this is the height. But if you lay it on its side, if you topple it over 90 degrees, then this is the base and this is the height. So it's always dependent upon your orientation. So make sure you understand that before you start solving your problems. I'll try to make the problems very clear about which is the base and which is the height. So our formula is this, and this is specifically for a rectangle. It doesn't work for anything else. If you're calculating moments of inertia, you need to look up some formulas for the different shapes, but we're only going to do prisms that are rectangular in shape. Okay, so our moment of inertia, I, is equal to the base times the cube of the height. The cube only goes with the height, not the product of those two together. The cube is only for height, okay? And then you take that product and divide it by 12, and you get moment of inertia. So this base is in inches, and it's multiplied by cubic inches. So we get a result in quartic inches. We'll talk more about that in just a moment. So I is going to be stated in the units of inches to the fourth power. Okay, this is what a problem might look like. So here we have a base of 2 inches and a height of 6 inches. So we're talking about a base down here of 2 and a height of 6 right there. And from that, we can go look at how to find inertia. So our inertia is going to be measured in quartic inches, so inches to the fourth power. It's kind of like squared, cubic, quartic, okay? Our formula we're going to use is the one we talked about earlier, base times height cubed divided by 12. So we plug in our numbers, 2 times 6 cubed divided by 12. And we get that the moment of inertia for that beam is 36 inches to the fourth power. One of the things I want to point out is shape is very dependent on orientation, or this moment of inertia is really dependent on orientation. So when it's upright like this, then this area here, we call that joist, and if we lay it sideways where the base is wider than the height, and we call that plank. And if you rotate this piece 90 degrees, that moment of inertia drops from 36 to 4. And that should be inches to the fourth power, not cubed. Sorry. And that represents about a 90% reduction in moment of inertia just in that orientation. So it's very important that you understand the orientation before you solve the problems, or your solutions will be very, very, very incorrect. All right, that's all I have for now. Thank you for watching.